school students. So this weekend my family decided to go and do our social distancing at our cabin in the middle of the woods, which is where I am right now. So our videos are going to be from the woods this week, and behind me you might be able to see this gigantic fort. My cousins have all worked together to build a fort out here in the woods right next to this stream. So let's go take a look inside. Hello, welcome to the fort. So our topic this week is polymers. So last week we talked about hydrocarbons and how to name hydrocarbons and what they are and how they're based on the element of life, which is carbon, and how they're non-polar, so they're different from water and salt and all the other things we might know of, that they don't dissolve in those kinds of things. So they're totally different than all the other things we've looked at so far this year. But the one huge thing that these hydrocarbons are part of is something called polymers. I don't know if you know the word part poly means many, and a polymer is just many hydrocarbons stitched together into a really long chain that can be hundreds of atoms long. It's incredible. But what are these things? Well, polymers are things like plastic. Any kind of plastic that you might have around your house is a polymer of some type or another. And a lot of times these chains are simply really long hydrocarbon pieces all stuck together. Each one of those pieces is called a monomer. Mono meaning one. So monomers are one piece, and so they might be something like ethene or ethane. Remember, eth means two carbons, so ethane is two carbon atoms with hydrogen atoms surrounding it. So if you take one of those and you detach the hydrogens on either end, you can actually couple them to the next ethene and then couple that to the next one, and so on until you get this really long string of ethenes all stuck together. So each ethene molecule is a monomer, and the whole chain is a polymer. And so you can do this with not just hydrocarbons, but with all other kinds of molecules that are based on a carbon chain. So we even mentioned last week that there are functional groups. Functional groups are something that replaces one of the hydrogens. So if we had an OH, which we said was an alcohol functional group, if we put those on one, you might get a completely different type of polymer than if you just use the normal ethene. So there's lots of different polymers. In fact, there's polymers all over the place. So I'm sitting in this fort made of sticks and trees and stuff. Wood is actually a natural form of a polymer. Trees and all other kinds of plants use a polymer called cellulose to give them the strength to stand up straight, which is why plant tissues are tough and stringy. If you've ever tried to mess with them or pull them apart, they come apart in little strings, which is that cellulose stuff. So there are natural polymers that come from nature that are built by living things and all that, but there are also human created polymers. So we have created dozens of plastics, dozens of polymers that help us do all kinds of stuff. All of them, because they're based on hydrocarbons, they actually are made out of oil. So oil is refined and is separated out into all these different pieces. Some of those are used to make plastic. And they're linked together and pieced together to make these big chains of plastic molecules. Now, that gives plastic a lot of really good properties. So plastics don't react with stuff very often, because they are non-polar, because they're based on the carbon chains. They don't react with stuff. You can put acid inside of them. You know at school that all the crazy acids that I've got are sealed in plastic containers. That's because plastic doesn't react with stuff. It's also really, really easy to mold and shape. If you tried to take a piece of wood and carve out a bottle with it, that would be so difficult. So even though it's a polymer, it's not very easy to bend and twist and make stuff out of. But plastic is. You can melt it, you can form it, twist it, shape it. and build all kinds of stuff out of it. Something really interesting that you can do is if you look at the bottom of plastic stuff, you will sometimes find a triangle, like arrow shaped thing, and I'm going to do my best to like show you this on this bottle. So right there, I don't know if you can see that, if it'll focus. Hello. But there is a triangle shape right on the bottom of this bottle. And the triangle has the number 2 inside of it. And that is its recycling number. So the recycling number tells you what kind of plastic it's made out of. This thing, I don't actually know the name of it, but it's a certain type of plastic. And if you look up recycling number 2, it'll give you the name of the plastic that it's made out of. The one type of plastic I do know is stuff like this. So this is a 2-liter bottle of soda, super common. All of these are made out of a polymer called polyethylene. So polyethylene is many ethylenes. Ethylene is the monomer, polyethylene is the polymer. Ethylene is just a fancier way of saying ethene. So that's literally just a huge long string of carbon with hydrogens. It doesn't have any of those weird functional groups. Super basic. And because of that, the plastic is super simple and easy to make, which is why soda bottles are made out of it, because you need a lot of them. And I couldn't actually find the triangle on this, but I do know that it's made out of this. Oh, there it is. Just kidding, there it is. Right on that little side. I don't know if you can quite see it there, but it's right there, and it has a 1 in the middle, telling us that it's made out of polyethylene. This might look familiar. This is a drinking cup, and this is another type of plastic. If you think about it, this is like tougher plastic than this type of plastic. This is really easy to squish and bend. This is a little harder to bend and it's stiffer, but it also crack easier as well. This, if you look on the bottom of here, also has a triangle. This one you might actually be able to read. This one has a number 5 in the middle, which stands for polypropylene, I think. Polypropylene, which is another hydrocarbon that is, prop was prop. I think prop is 4. So polypropylene means you have a propane molecule stitched together with other propane molecules to make this big long polymer chain. So polymers are super helpful, and they can do a lot of different stuff for us. People do make the objection though, okay, so these things are made out of oil, and so you're just causing more global warming and like using more oil-based products. Can't you use something more natural? And in some cases, it's true, we could use things that are more natural. If you think about at the grocery store, all the times you get a grocery bag, that plastic is made out of oil. So what if you instead used like paper bags or used cloth bags? That would save a lot of plastic. So there are some times when you could use something that's not plastic. But other times, plastic is really the only thing that'll work. Or there will be nothing that works quite as well as the plastic does. So things to remember is plastics are polymers. They are very, very helpful for us, but there are some downsides to using them. A polymer is made out of a monomer, and they're long chains of hydrocarbons stitched together. All right, that does it for now. I will see you guys next week.